Alright, let me delete this older video. Had to pause because or what the fuck happened? What is happening? Okay. Oh, I was hungry and then I forgot that my groceries were ordered and were delivered outside fucking like almost 2 hours ago. So, oh god, if the milk smells bad tomorrow, I'm gonna be so fucking annoyed. But it is what it is. My mistake. I moved the fucking phone. Oh, I put it on my bed when groceries were on the way. Ah. So a pseudo random number generator by definition is used to create multiple numbers in sequence. We don't say, hey, pseudo random number generator, give me one random number. Oh, maybe it looks random. Maybe. But what we do is we give it a number and it spits back multiple numbers. So it's not, I was reading this wrong because I didn't have food in me. It generates a sequence of numbers. So 458, 2, 76, 4 billion, 3, 4, 2, 187. It spits back a sequence of numbers, and the differences between them, the numbers that we get, seem to be random. So we get a number and then we do a bunch of shit to it and spit it back. And in that same number, we do a bunch of shit to it and spit it back. So it looks like it's not related. It looks like it's random. It's not call and give me one number. It is instead start with some number, in this case, 0. We have some sort of algorithm to do shit to it. And we spit back 100 numbers. And then in this case, when the count is divisible by 10, so if the count remainders 10 is 0, it's divisible by 10, go to the next line, just to make it seem better. And then we're doing \t, so tab between the numbers. That way we can show you a whole shitload of numbers in the whole sequence of them. This one, then this one, then this one, then this one. The whole sequence. This is the big ass sequence. This is not a sequence. This is a sequence. This is a bigger sequence. Boom. This is where the pseudo random comes. So, let's say there's a boss fight, and every time in this boss fight, or every time you do this boss fight, the pseudo random number generator spits out some locations. Let's see. You could have a map generator. You could give the map generator a starting number, like 100, and then have it do a bunch of shit and spit back a bunch of POIs and where their location should be. And they should be somewhat random-ishly distributed. Yesterday we saw there's an issue here though. It's alternating even odd, even odd, even odd, so that's not random. Should be like odd, 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 even, odd, odd, even, odd, even, odd, even. Just weird shit. So, that's what this meant. I didn't know I couldn't read what was happening or understand the words earlier here. The sequence of random numbers. Because when we look at them all, they don't look related. They look randomish. There's a lot that are in just the thousands, and a lot that are a lot bigger than that. It seems like there aren't too many that are in the, like, the 10,000s. Or, oh, sorry. Never mind. Seems like, yeah, it seems randomish. I was gonna say it sounds like a lot less than a third. It's under 10,000, but it's not fully true. Okay, so the point here is we're saying generate 100 numbers. We're starting with some number. And we have to store something between calls. That way, because if this started at 0 every time, this is the same result every time. In fact, it's just this, because 0 times this, plus this. Or rather, the result is whatever the remainder between these two is. So, we instead store that value and then update it. So, in this example, we're starting with 0, and we're doing it 100 times. In this case, let's just do it 50 times. So, and let's do num count, and we'll start them at 0. I guess we want the first one, and then we'll just go through 50. Desired num count, and that's 50, and we want this to be through 50, and then increment num count. Okay, and then we'll just do desired num count, and that is 50. I'm getting used to the for loop stuff. Boom. Boom. And in this case, we could just do a null statement. And there's also not a value here. Excuse me. What are we actually going to be doing? Well, we need user input and to display excuse me. PRNG sequences. I'll put 100 nums. Sorry, 50 pseudo random numbers. Or rather, output a pseudo random sequence of 50 numbers. And so we'll start at 0, and we'll just call a function 50 times. And what this function will do, it's a void because we're just displaying stuff. We're not doing anything else. And it'll be called pseudo pseudo random number ish. Yeah, I guess that makes sense. It's fine. Okay. Print pseudo random number. It doesn't take any parameters. It has a static unsigned int called current pseudo random num, and it's 0. So we start at 0. And this will be initialized on program start because it's static. We're not returning anything. We will output, well, first we're going to assign it. So we can just do this here. Okay. Yeah, why not? We'll just assign it to be itself times other craziness. Instead of it being multiply equals, we're doing a bunch of stuff here. So we're doing it times some big numbers plus this. Okay. And then we are outputting current pseudo random num. And here we are calling print pseudo random number. Okay. And afterwards, if num count remainder 10 is 0, meaning it's divisible by 10, output an inline. And actually we want to output a number and then output we want to, let's see. I guess we could just return the number. So we could say return an int or return unsigned int. Doesn't really matter. Yeah, let's do that. So return unsigned int. This guy's static. And here actually instead we're just going to output this. That way we can do all the outputting together. And this will be tab. I've never even used that. Cool. Is this cool? Oh yes, that's true. Uh-oh. What is happening? We're outputting. Oh. Because it's an unsigned int. And I think it was doing 8-bit. Let's see. Oh yeah, because we were converting. Oh, true. So we could do static cast to an int. This guy. Why is it doing that? What if we just did a regular ass int? Oh, why is it printing in hex? What if I just did plus 10? And we wouldn't want to actually do it like this, but oh. We're outputting. Oh. That's why. We're outputting, I guess, where this is in memory? Is that what's happening right now? I was gonna say it shouldn't be. I mean, we're not doing a uint 8, so it's not like we're outputting a character and it's some kind of weird thing. It's outputting hexadecimal for some reason. Alright, see what we're missing here? Oh, okay, yeah, that's fine. We can leave this as unsigned int. That's fine. Anything else? Okay, cool. Yeah, the issue here was that we were printing. What was this? Was it the same thing? Yeah, it is. So it looks like when you do this, you're actually printing the location in memory of where the function is, maybe? This is a big ass piece of memory here. This is 1, 2, 4, 8, 16, 32, 64, 128, 256, and then, but bigger. It's probably, oh, it's actually more than that because this is in hex. Right, so this is in 16s. Oh my god. Wait, is that really? 5 16s and then 2 56s? Oh no. This is a gigantic fucking number. And it looks like it's printing, we're printing the identifier, as we learned yesterday. You can use the identifier when you're using standard at exit. You call the identifier, so we could print pseudo random number if we wanted to for some reason. If we wanted to call that function whenever we call standard exit, we could tell the compiler that, or tell the program that. Hold on. I guess tell the compiler that so that when it sees standard exit, it runs whatever standard at exit is indicating. But here, or passing it as an argument, is a function pointer. But now we're actually calling this function. So what we're doing here is printing this, and then let's see. There we go. Just, numbers are just too big. Oh, this is 10. Let's just do 5. It's just too many damn numbers. How many did we do here? Did we do 5? We did 10. Oh, you just had so much room. Oh, and the numbers here were... Oh, also true. He wasn't just printing the big numbers. He was doing a mod, but I mean, it doesn't really matter. Let's see how random they look. Oh, they're not random at all. It looks like... So we're starting with a number and then that, and then eventually we hit this number, and we hit this one, and then for some reason here the number stops changing. Same thing. It stops on the 10th. The 10th number, and then... Huh. What if... Is it just because it keeps getting bigger? It is increasing until 4, 4, 1. What if I did this remainder? And again, what is it here that makes it so the numbers after the 10th stop changing? Well, let's see what they're doing. Yeah, Z is this static number. Yeah. Oh, well, yeah, I guess the parentheses here aren't really needed. Doesn't change anything. Hmm. Is it an issue with the printing? Oh, because each time So like if we just said 10 here, the numbers are all different. But if we say 11, what if we just took this and made these like super small? Oh, so it's okay here. And then what if we bring this back up to 50? Is it just number choice? Oh, yeah, it is. So what, did it just stop wrapping around for some reason? Was he returning and printing? Yeah, he was. Yeah, he's doing it the same way I was doing it. Okay, so there's a cutoff point where, like, the wraparound should be different now, because if I had some number that was way too big, and then I added it to a number, and it did wraparound. If I then added, well, I guess that's not the case. Well, if I instead added the number that was one more, it should just be one more. So I keep on changing it. I don't know why we would end up getting the same number. Oh, in here, why are these numbers getting so fucking huge? Oh, because we just keep on multiplying it by 5. 5 times this, times this, times this, times this, times this, times this. Oh, we can see where the wraparound's happening. 45, 227. Oh, here we go. The wraparound happens right here. Yeah. Yeah, because that's when we get to billion, and we can't have 5 times a billion. It's too big for an unsigned int. I think it only goes to 4.6 billion or something. But he was multiplying it by much larger numbers. But he was also modding after. And then what was he doing? Was he just returning? Yeah, he was returning it. Sorry, returning the remainder. Okay, so the numbers get small. So what? Is he using a larger static unsigned int? He's changing it and then he's remaindering it. And he's just outputting the function call. Let's see what happens if I print his. Okay, so his is unique. Huh. Mine is not. Why? I don't know. So what if I just took these numbers just to see? So his numbers work there. But all of a sudden if I try and change this to 500, wonder why that is. Like the number has to be sufficiently large? Oh. And even then, what is unique about his fucking number, bro? So it's his multiplier. If I do 10 times bigger than it, it doesn't work. And if I do 10 times smaller than it, it doesn't work. What the heck? What if we do another number here? Is it with even numbers? It is. Oh, that took too long. Mmm. Something here with, well, okay, we have to do an odd multiplier. Because if you multiply evens, we just get even shit. And for whatever reason here, when we get something that's even, the number is repeating. But why? What if you just do times 2? Oh my god. It's because it's so dumb. Once we hit wraparound, if we have an even number, we are multiplying the number by itself some even number of times. So, we're getting the same number. Well, why even though? Hold on. So if I have the number 2 and I multiply it by itself some large number of times to trigger wraparound, and I do it an even number, once the number is already big enough, It it doesn't really matter. Somehow it ends up doing the same thing over and over again because we're multiplying it by an even number. So I'm picturing a number and somehow it's looping around and it's landing in the same spot. But I don't know why it's landing in the same spot, because if the number is bigger, then it should be wrapping around further and it would just land on an even number. Or if it was odd, it would still land on odd, just like adding 2 to 7 will forever give you an odd number. 7, 9, 11, 13, 15, 17, 21, 23, etc. Okay. I was just wondering what the fuck was going on with mine. And it was simply that I chose an even number. And I shouldn't have. Okay. So, we generate a bunch of numbers. Cool. And we're keeping the value, and we keep on going. Just like if we stored it as what, like a static? And then we kept doing +1? Yeah. This one. And then adding what you already had. Boom. This. Call it again. This is a bajillion something. Do something to a bajillion something. Keep on going. Okay. Uh-huh. Mm-hmm. Mm-hmm. Also true. Yeah, just harder to predict. Just because there's more shit happening. It's wrapping around in different ways, and maybe sometimes the wraparound happens, other times it doesn't. So it's hard to predict what the where the wraparound actually is, and its mod or its remainder too. So the remainder kind of tells you where the wraparound is. Well, no. It's just telling you that at some point you're wrapping around, and we're doing a remainder of something to get here. And the highest number you get is one less than the remainder. Yeah, it's deterministic. We pass it the same number, same stuff comes out. That's a big come up. I just needed to eat and lock in. So it might be true that random number generators that generate larger random numbers are more intensive. So you could have a small real random number generator. There's something that's closer to being random for smaller numbers, like maybe up to 1 million. And then there's 1 million different combinations that each one yields so many different numbers that it feels more random. Because each sequence already kind of feels random, and then there's 1 million combinations, but maybe not still, because there's still only, you're still limited by how many unique seeds there are. Ow! Ow! Stabbed by a Dorito. Oh, instead of 0 or some other number. The seed is probably determined by somebody. Or, I mean, in this case, it sounds like 0 is technically the seed from the previous PRNG. Yeah. Because again, this shit ain't random, yo. So, you know the seed, you know the thing. It's like Minecraft. So it does this, LCG. Whatever the fuck that is. And that returns this number. Oh, okay, here we go, actually. I wasn't looking at main, whoops. We get output from the user. We set a global variable to be that, and then we use that global variable instead of just passing it here as a parameter, I guess. Makes sense, because we wouldn't want to do that over and over again. And if we passed it as a parameter, it would get passed every time. So maybe this makes sense. Alright, I'll look at this part harder tomorrow. Seeding a PRNG. Seeding a PRNG. Okay.